In our next section, we're going to look at the implementation of the virtual device context on the Nexus 7K, and we're going to start with the basic initial configuration dialog, look at how we configure the admin VDC, how do we do interface allocations, and then what are the other specific attributes that we can modify, for example, like the resource limitations, the resource templates that are going to apply to the different virtual device contexts. So if you take a look in the file share, there's also a copy of the physical diagram that we're going to be using for the rest of our examples. And let me go ahead and open up the physical diagram here. If you take a look at the first page, basically what this represents is two physical 7K chassis, where specifically the chassis are going to be broken up into even numbers and odd numbers, where these four are going to be chassis 1. So we'll call this 7K1, and the even numbers, so the odd numbers are 7K1, the even numbers are going to be 7K2. What this is representing here in the diagram is the virtual context that ultimately have the interfaces allocated to them in the data plane. So the topology as it looks now, the 7K's configuration is blank. We're going to go through the initial config dialog and then the interface allocation in order to make it look like the logical topology that we see here in the particular diagram. Okay, so let's take a look at the CLI. And here I have the blank switch, so I erased it, erased the config and reloaded. What it starts with, it says, do you want to run power on auto provisioning? Essentially what this is the equivalent of auto install for NXOS. So the idea is that you're deploying the chassis in some remote data center location. You can configure a provisioning server that the 7K just boots and downloads the config from it and then automatically runs that config file, as opposed to you having to manually configure it from the CLI. In our case, we're going to skip this. So it says, do you want to abort POAP, so auto provisioning? So yes, we're going to abort that, and we're going to go through the normal setup. Okay, so there's a couple questions that in the dialog it's going to ask us first. So like, what's the user, or what's the password for the admin user? It says, do you want to enable the admin VDC? Here I'm going to say yes. Again, what the admin VDC allows you to do is to have remote management to the box and to manage all the VDC allocations and creations without having to have that particular VDC be in the actual data plane. So in the previous releases, there used to be only 4 virtual device contexts supported, and the one that was used to manage the box was one of the contexts that you would use for normal data forwarding. But in the current versions, normally you would want to have a separate admin VDC that's going to be used just for the management of the chassis, which is not going to be in the actual routed data plane in the regular network. Okay, so do we want to enter the initial configuration dialog? No, we're just going to go to the regular CLI. Okay, next we're going to log in. So the default username is admin and whatever password we create. And let's simply look at the show run output. Let's look at what the default options are. Okay, we can see that this particular box is running NXOS version 6.22, which is kind of a middle of the road release. There are some versions after this. There's version, I believe, up to 7.1 now. It says that this is the admin virtual device context. Okay, we can also see that we have a virtual device context that is for actually this here is the name of the box. Let me go ahead and change that for clarity. Let's say that this is, host name is going to be N7K1 admin. And let's show run again. What this is saying is that there is a virtual device context named N7K1 admin. The identifier is 1, so internally each of the contexts get a number. And it says what are the different resources that the virtual context is allowed to use. Now, as I mentioned previously, even though we are doing virtualization physically in the data plane for the context, meaning that we're going to take a physical port and we're going to assign it to one context only, And if we want to route traffic or switch traffic between the virtual device contexts, we're going to have to go out the chassis, out a physical cable, and then come back in. So the data plane separation is physical, but on the back end, the control plane is shared between the contexts. So what this means is that based on the memory of the supervisor, there's going to be a limit to how many IP version 4 unicast routes we're going to be able to hold in memory, or how many VLANs that we're going to be able to create at a maximum, or how many port channels that we're going to be able to create. So essentially what this is saying is that this is the template applied to this particular context, that if we wanted to say that user can create virtual routing and forwarding instances, so virtual routing tables, but at a maximum they're going to be able to create 10 of them. Or from a unicast routing point of view, the amount of memory that we're going to allocate is going to be 32 at a maximum. Okay, so we can see these are just the defaults here. And pretty much that's it. There's not really a whole lot else that's here by default in the admin context. But the big thing to note here is that we do not see any interfaces that are in the admin context. So normally we would see like Ethernet 1.1, Ethernet 3/5, just like we would on a regular catalyst switch when we look at the show run or look at the show interface's status. Now, the idea behind this is that since we have this specific context that is just used for administration, we're not going to be assigning any interfaces that are actually in the data plane. The only interface that's going to be assigned to the admin context is going to be the management Ethernet interface, which is this one here. Okay, so the management Ethernet, this is a physical port that is located on the supervisor module. So if we were to look at the specifics of the supervisors, let's go ahead and look for the 7K data sheets. So let's go to Nexus products, 7K data sheets, and let's say the Nexus 7000 supervisors. And I don't know if we're going to get, there we go. Okay, so a little bit better picture. It's still kind of low res, but what this is showing here is that there is the console port. This is what would go to directly to your serial port or your access server if you have like a terminal server that you're using for remote management. That's going to be for out-of-band serial management of the box. But then in addition to this, we have the management Ethernet port. This is going to go to a regular Ethernet switch that's going to be used for our out-of-band management when we go to either Telnet or to SSH, or we go to run SNMP, we go to run syslog to the box. The idea is that we want to keep this traffic outside of the regular data plane of the user traffic. So if the user is maybe doing like a denial of service against the network, that's not going to affect our management of the boxes, or it's not going to affect our logging of the boxes. And you can see that with the default configuration, the management interface exists in its own routing table, which is in a separate virtual routing and forwarding instance. So the idea of this is that if I configure OSPF in the global routing table, or if I configure BGP routing in the global routing table, that's not going to affect the management connectivity where we're telnetting or SSH to the boxes to actually configure them or to monitor them. So this is not configurable. That's going to be there automatically by default, the management interface, and then you're going to apply either an IP version 4 or an IP version 6 address, or both of them in order to actually do the management. So here in my particular case, I have an access server. Let me connect to the access server. So I have an access server that is connected to that management Ethernet segment, where if you look at the config here, this is actually from a previous configuration. The IP address for management of the box is 192.168.0.70. So this belongs to the admin context. This means that if I were to telnet to this, or if I were to SSH to this remotely, I would have entire control of the entire chassis. Now we'll see that this is different from the management interfaces that are going to be assigned to the individual user contexts, because if you telnet or you SSH into a context, you are not able to switch back to the admin context. And it has to do with the basic principles of authorization of how you would want to do the inheritance of the authorization attributes. So the way that you would think about this is that you have the admin context at the top, and the admin context then is going to control the different user VDCs. So we have user VDC 1, we have user VDC 2, and if we connect from a management point of view into the admin context, we are then allowed to switch to the user VDCs in order to do any configuration or management of them. But if we were to come in the management interface of the user context, we're not allowed to do the opposite. We're not allowed to switch from the user VDC back to admin. You would have to connect for remote access to the admin context in order to do that. And it works the kind of the same way as the ASA firewalls do when you're looking at security contexts. And the idea is that you have your super user, which is going to be a member of the admin VDC, and then you have your customers, or you have your read-only users that have their user database exist in the user VDC, and then they have separate sets of authorization. Okay, you can also see that by the default config, there is this username that is admin, and the admin's role is network-admin. Okay, this is what NXOS calls role-based access control, or RBAC. The network admin, you could think of this like the root user. So network admin is allowed to make any changes in the admin VDC, but they're also allowed to connect to the user VDCs in order to make any changes in those as well. Okay, next step, let's look at what are the physical properties of the chassis. So let's look at the show modules. And we can see in this particular case, there are 3 different modules. There's the supervisor module 1, so soup 1, and then there's 2 different line cards. We have an M132XP, which is our layer 3 card, and we have an F132XP, which is our layer 2 card. Now the F1 in the M1 module, so these are the first generation cards, these can exist in the same virtual device context at a time, and the F card, being layer 2, does not have layer 3 native routing capabilities on its own, but it can borrow those capabilities from the M card. So if we're using the F ports to connect down to our aggregation switches, or we're using them to connect down to our access switches, and we're using the 7K for layer 3 routing, we need to make sure that there is at least one M port in the virtual device context in order to allow us to do layer 3 routing. Now, as I mentioned previously, if we were using the newer generations like the F2E or the F3 cards, those do have native layer 3 routing built into them. So in most newer cases, it's not really that big of a design issue. But originally, or if you have a deployment with these older cards, then yes, it is going to be an issue you need to deal with, that the F card on its own does not have layer 3 capabilities. Okay, so next thing we're going to look at is the show VDC membership. Okay, the VDC membership is going to show you what are the different contexts that we have created and what specific ports are allocated to the different contexts. Now we can see in this output it says that there are 2 contexts created. There's context number 0, where context number 0 is going to be used for any unconfigured or unallocated interfaces. And then we have context number 1, which is our admin VDC. Now the admin VDC doesn't have any regular line cards assigned to it, so it doesn't have any regular ports in the data plane. And if we were to look at the show interface status, we can see that the only port that's assigned there is going to be just the management interface. Okay, but again, the point of the admin VDC is just going to be for creating other VDCs, for managing them locally, and for managing them remotely. So next step is that we're going to create a user VDC. So in order to do this, we're going to go to global config, and we're going to say VDC, and then we give it a name. So we'll say that this is VDC 7K1. Okay, so it takes a minute for the control plane to actually build the new context, because it's creating a logical copy of the processes behind the scenes. So for example, if we create VLANs, we're going to have separate spanning tree instances that are specific to that virtual context. If we create layer 3 interfaces, if we create layer 3 routing protocols, those are going to be separate instances that belong just to that individual context. So in other words, if we have context 1 and 2, and both of them have VLAN 10, it's not the same VLAN. Or likewise, if we have context 1 and 2 and we have OSPF 1, it's not going to be the same OSPF process. Only if we have a physical cable that is connecting the two contexts together are the processes going to be running together. Okay, next it says the VDC has come online. So if we look at simply the show VDC, it shows us what particular context that we currently have configured. Okay, so it says that we have right now two different contexts. We have VDC number 1, we have VDC number 2. Their names respectively are N7K1_admin and N7K1. Okay, also it says the type of context. The first one is admin. It's kind of cut off there. It's wrapped down here. But the second one, the type is Ethernet. Okay, Ethernet context basically means that this is a user context. This is where we can assign our layer 2 interfaces. This is where we can assign our layer 3 interfaces. And it's going to behave like a normal standalone switch. So it's going to have a management interface configured for it, and it's going to have the physical data plane ports, but based on how we are specifically assigning them from a software configuration point of view. So next, if we look back at the show VDC membership, we have context 7K1 created, but we don't currently have any ports that are actually allocated there. So the next step is that we're going to choose what interfaces do we actually want to do an allocation for. So what I'm going to do is go back to the VDC, let's say VDC N7K1, and I'm going to do two different allocations. I'm going to allocate a port from the M card, which is going to be Ethernet 1.1, and I'm going to allocate a port from the F card, which is Ethernet 2/1. So under the context, we say specifically we want to allocate an interface. And this is going to be Ethernet 1.1. It says the entire port group is not present in the command. Missing ports will be included automatically. Moving ports will cause all config associated with them in the source VDC to be removed. Are you sure? Okay, or in other words, what it's saying is that this is a disruptive process. That if the port was already allocated to a different VDC, it's the same as physically pulling the line card or physically pulling like the port adapter from the physical router or from the physical switch. So the configuration is going to be lost when you move them between contexts. Okay, the first portion of the output where it's talking about the port grouping, I'll come back to that in a second and talk about what specifically does it mean. Okay, next we're going to allocate interface Ethernet 2/1. Okay, it says the same thing. It says that not all ports in the group are present, and this is going to be a disruptive change. It's going to delete the config if you move it. Okay, next there's an error. It says one or more interfaces from a module of the type not supported by this VDC. Okay, next let's look at the show run VDC. We're going to see what is it talking about here specifically. Okay, this says that in VDC 7K1, and you'll see that this is different depending on what particular version that you're running. The default value here of what modules are allowed in the context, it says M1, M1XL, M2XL, and F2E. Now, the reason that this is a potential issue is that not all modules are allowed to exist in the same context at the same time. So if we have an F2 card, where F2 card is typically used as your fabric path spine switch, that layer 2 only card cannot exist in the same VDC as an M card or as an F2E. So based on the configuration here, we're saying that the F1 card is not allowed in the VDC. It means that I cannot move that port into the context. Now we can change this value, but it is important to note that when you do a physical design with this, not all of the variations are going to be compatible. So you need to make sure that you have the type of line cards that are supported if you want to combine them into the same type of VDC or the same VDC number. Okay, let's say next limit resource based on the module type. We're going to allow F1s and we're going to allow M1s. It says this will cause all ports of unallowed type to be removed. Do I want to do this? Yes. Next, if we look at the show run VDC, it says now these type of modules are going to be allowed. If we look at the show VDC, we can see and actually this is under, let me copy this to Notepad. I believe this is under the type that it's showing. No, it says LC for line card. What it's saying is what type of line cards are supported. In the second VDC that I created, it says line cards of M1 and F1 types are allowed. So if I was to say M1, F1, F2, that would not be a valid combination because F2 modules cannot exist with M cards at the same time.